So let us see how to perform deletion in a B tree with an example. So let us take this particular tree, the B tree. Okay. So remember that B tree, the root node should have minimum two children. Okay, and all other nodes should have their minimum number of children, which is mandatory. Okay, fine. So we are taking a B tree of order 5. So any node can have maximum 5 children and 4 keys, and minimum any node can have 3 children and 2 keys, except the root node. Root node can have minimum 2 children and 1 key. Okay, fine. So with this understanding, let us proceed. So this is the original tree. So first we want to delete 64. When you delete 64, just locate 64 where it is. It's greater than 50 and less than 80, so come this way. Again it is greater than 60 and less than 70, so take this way, it's here. So after deleting, if you delete 64, will this node will have the minimum number of keys? So minimum number of keys is CL of m by 2 minus 1. Yes, it will have. There is minimum 2 keys is required. Already it has 3, so it will have minimum number of keys. So there is no issues. We can directly delete 64. Okay, you can strike off 64. So this is the updated tree where 64 is removed. Okay. Next, let us see how to delete 23. So where is 23? 23 is less than 50. So take this path. Again, it is greater than 20, greater than 10 and greater than 20. So take this path. So here 23 is there. Now if 23 is removed, what will happen? This node will become deficient, because minimum every node should have 2 children for a, 2 keys in a B tree of order 5. So this node will become deficient. Now this deficiency should be removed. So it can borrow either from its left sibling or from its right sibling. Now it has only left sibling. So is the left sibling has the minimum, is the sufficient keys to borrow? So the requirement is it should have CL of m by 2 keys. Okay, yeah, it has 3 keys. It has 3 keys, so it means it can give 1 key. Okay, so now we perform. So now we are borrowing from left side, so we call it as right rotation. We perform right rotation. So this you have to locate the particular key of parent which is in between these two nodes. Okay, so this 20 of the parent will come down. Okay, and this 16 from the nearest left sibling will replace this 20, right? After this is the tree is sorry, this 16 of will replace this 20. Okay, after this is the tree is the deficiency is removed? Yes, the deficiency is removed. Okay, so this is the updated tree. After that, what we have got? Okay, 14, 15 and 16 goes to the top. Fine. Okay, next let us see how to delete 72. So 72, it's greater than 50 and less than 80, so take this path. It's greater than 60 and less than 77. Okay, so 72, right? Yes. Yeah, it's greater than it's greater than 60, greater than 70. Okay, and less than 75, so take this path. Okay, so here is 72. Now 72, if we delete, this node has only 2 keys. If we delete this key, this node will become deficient. So it should borrow either from its left sibling or from its right sibling. Now it cannot borrow from the left sibling because left sibling already having minimum number of keys, which is 2. So it has to borrow from the right sibling. So can it borrow from the right sibling? Yes, it has 3 keys. So 1 key can be borrowed from the right sibling. Okay. So now what happens? You have to again locate the middle key of the parent, which is coming in between these two nodes. That is 75. So 75 will come down. Okay, but now 75 is greater than, it will come in the right end. Okay, So in this node it will be something like this, 73 will be first and then 75 will be there. Okay, right? Okay, so like this node will be changed, so it will be 73 and 75, right? And okay, and this 77 will replace this 75, 77 will replace this 75, 77 will be removed from here. So this will be the resultant tree after deleting 72. Okay, so this is the resultant tree. So here what we call is, here we are performing, we are borrowing from the right sibling, so it is called as left rotation. We are performing to the left, we are rotating to the left. Okay, fine. Next let us see how to delete 65. Okay, so where is 65? 65 is greater than 50 and less than 80, so take this path. It is greater than 60 and less than 70, so take this path. Here is 65. Now if you delete 65, it cannot borrow either from its left sibling or from its right sibling, because both of them are what you call, both of them have minimum number of keys. This left sibling also having minimum number of keys, right is also having minimum number of keys. Okay, so what should be done? So now we have to go for merging. Okay, so this node can be either merged with its nearest left sibling or with the nearest right sibling. Okay, let us see how it will merge with the nearest right sibling. Okay, if it want to merge with the nearest right sibling, then again you have to identify the, in the parent you have to identify the middle key, which is in between these two nodes. Okay, so the middle key is 70, so this 70 will come down, so this node will become like what, 65, 68. After merging it will become 65, 68, 70, 73 and 75. Okay, and the one which we are deleting is 65. Okay, so no 65 is here, 65 is deleted. Okay, so 68, 70, 73 and 75, this is the new node. Okay, this is the new node, right? Okay, and in the top its parent is what, its parent is 70, we have brought down. Okay, so 60 and 77 is, so after removing, is the parent is not deficient, that also we have to check. Yes, parent is not deficient because it is having two keys. Okay, now 60's left pointer will point as usual to 51 and 52. Okay, 51 and 52, and 60's right pointer will point to this particular new node which is created, right? 68, 70, 73 and 75. Okay, you can see this new node as it is having only max keys, it cannot be more than max keys, right? Then 77's right pointer will always, as usual, it will point to 78 and 79. Okay, so this is the update that will happen after deleting 65. Okay, so this is the updated tree. You can see here 60's left pointer will point to this. Okay, and 60's right will point to 68, 70, 73 and 75, and 77's right will point to 78 and 79, right? Okay, fine. Say next we want to delete 20. Okay, so 20, where it is, 20 is less than 50, right? It's greater than 10 and it's greater than 60, so follow this path. Here is 20. Now if you delete 20, this node will become deficient. Can it borrow from its, it has only left sibling, can it borrow? No, it cannot borrow. Okay, it cannot borrow. So what should we do? We should again merge. We should merge. Okay, now if you merge, what will happen? For merging we have to identify the minimum middle key in the top, in the parent. Okay, the middle key is what, 16, so 16 will come down, so merging will become something like this, 14, 15, 16 and 27. Okay, this is the new node which is created. This is the new node which is created with these values, 14, 15, 16 and 27. Okay, and the parent is now only 10. Parent has only one key, that is 10. Okay, right, and parents 10's parents right pointer will be pointing to this node, parents left will be pointing to as usual 4, 5 and 6. Okay, now after deleting you have to check whether parent has become deficient or not. So in this case, is the parent has become deficient? Yes, parent has become deficient, because it is supposed to have minimum 2 keys, it is having only 1 key. Okay. So can 10 so now this deficiency should be removed. Can it borrow from the nearest sibling? It has only right sibling. No, it cannot borrow, because that also it also has only minimum keys. So again we have to go for merging. So now if you merge, what will happen? Now if you merge, what will happen? Now if you, so here we have only 10. Okay, so 50 will come down, the 50 of the root will come down, so it will become 10, 50, 60 and 77. 10, 50, 60 and 77. Okay, so it is not 1 minute, so it is not just 10, it will become what? It will, this node will become, as 50 of the parent is coming down. Okay, after deleting 20, all these things are happening. Okay, so 10, 50, 60 and 77. Okay, this is what 10's left pointer will point to this 4, 4, 5, 6. 10's right pointer will point to this 14, 15, 16, 27. Okay, right. 60's left pointer will point to 51 and 52, this one, right. 60's right pointer will point to 68, 70 and 73, 75. Okay, 77's right will point to 78 and 79, right. So this is the change that will happen after you delete 20. Okay, so let us see. So after deleting 20, what will happen? In the root will have only 80. In the root will have only 80. Okay, and to the left of 80, what we have is 10, 50, 60 and 77. Okay, to the left of 10, what we have? 4, 5, 6. To the right of 10, what we have? 14, 15, 16, 27. Okay, to the right of 50, what we have? 51 and 52. Okay, to the right of 60, what we have? 68, 70, 60, 68. To the right of 60, to the right of 60, what we have? 68, 70, 73 and 75. Okay, here 70 is also there, but I think next we are deleting 70, so I removed 70 from here. So here 70 is also there at this point, here 70 is also there. Okay, 68, 70, 73 and 75. Okay, and to the right of 77 we have 78 and 79, right. So this is the change that is created after deleting 20. Okay, fine. Next, let us see how to delete 70. So 70, locate where it is. It's less than 80, it's greater than 10, greater than 50, greater than 60, but less than 77. So follow this pointer. So here is 70. Can we delete 70? It's a leaf node. Can we delete? Yes, we can delete it directly, because after deleting also this node will have minimum number of keys, so it can be deleted directly. So just remove 70, that's it. So the resultant tree will be this, 70 is removed. Okay, fine. So next let us see how to delete 95. 95. Okay, now where is 95? Okay, so in this tree itself we are seeing. Okay, so here let us see how to delete 95. So now say 70 is removed, 70 is removed, forget about that. Okay, so 95, if you want to delete, how you will delete? So 95, first locate 95, it's greater than 80, so it's here 95. Okay, so 95 is not a leaf node, it is a non-leaf node. Okay, so how will you delete from a non-leaf node? We have to identify either in order predecessor or the in order successor. Okay, here if you take the in order predecessor, it is 93, but if you, it should be replaced with 93. Okay, if you replace this with 93 and if you delete this 93, then this node will become deficient. Okay, so let us see the in order successor. What is the in order successor? In order successor is 100. So this has 3 keys. So if you replace 95 with 100 and delete this 100 also, this tree still it will not be deficient. Okay, so let us go with in order successor. So in order successor of 95 is 100. So replace 95 with 100, replace 95 with 100 and just remove this 100. Okay, this is how we delete 95. Okay, so after deleting 95, this is the resultant tree. Okay, along with 90 we have 100 and 90's right child is 110 and 111. Okay, fine. Next let us see how to delete 77. So where is 77? 77 is less than 80. So here it's greater than 10, greater than 50, greater than 60, it's here 77. Okay, now 77 is not a leaf node, so what it should be done, it should be replaced with the either in order successor or in order predecessor. Now if you go with in order successor node is always already having minimum number of keys. Okay, so let us see the in order predecessor. So in order predecessor is 75. This node is having more than minimum number of keys, so let us go with in order predecessor. So in order predecessor is 75. In order predecessor is the highest value in the left subtree, okay, of this key. Okay, so 77 will be replaced with 75 and this 75 can be removed. Okay, so this is what will happen after deleting 77, right? Okay, now 75 has come to the top and to the left of 75 we have 68 and 73. Okay, right. Now let us see how to delete 80. So 80 is nothing but the key of the root. Okay, so if you want to delete 80, again you have to find the in order successor or the in order predecessor. So if you see the in order predecessor, it is 79. This node is having already minimum number of keys. Okay, so if you delete this 79 after replacing this 80 by 79 and if you delete this 79, this node will become deficient. So let us see the case of in order successor. In order successor is 81, it's here. Okay, so in order successor will be always in the leaf node. Okay, so the one which comes, I mean the smallest value in the right subtree, the smallest value in the right subtree of 80 is 81. Okay, and in order predecessor is the largest value in the left subtree, that is 79. Okay, so in order successor is 81. So this node is having more than minimum keys, so this 80 can be replaced with 81. 80 can be replaced with 81 and this 81 from the leaf can be deleted. Okay, so this is what will happen after deleting 80. This is what will happen after deleting 80. This 80 will be removed. This 80 will be removed. Okay, fine. So this is the resultant tree what we are getting. Okay, so 80 goes to the 81 goes to the top and to the left of 90. Now we have 82 and 89. Okay, fine. So now let us say we want to delete 100. This is 100. Here actually you are having 110 and 111. It's not visible. Here we have only two keys. One is 110, other one is 111. Okay, let's verify. It is 110 and 111. Okay, so now if you want to delete 100, what can we do? It cannot take either from its it has to take. Okay, but the in order successor after in order successor I mean in order successor also having exactly minimum keys and in order predecessor also having, I mean in order, this is in order successor, the in order successor node is also having minimum number of keys and in order predecessor node is also having minimum number of keys. Okay, so you can go with either in order successor or predecessor, but the node will become deficient. So to remove the deficiency we have to merge. Okay, so we can replace this 100 either with 93 or with 110. Okay, either way we can do, right? But after replacing, what will happen, the node, this node, one of the node will become deficient. Okay, so let us replace with 110. If you replace this with 110, what will happen, here 110 will come, 110 is removed here, 110 is removed here. Now this node has become deficient. Okay, now to remove the deficiency, what it has to do, it has to borrow from the neighbor. Can it borrow? No, there is no sufficient keys, so it has to merge. For merging we need the middle element of the parent. So middle element or middle key is what, 110. So bring that down, so it will become what, 92 93, 110 and 111. So this will become a new node. This will become the new node. Okay, and that will be pointed by the right of 90. That will be pointed by the right of 90. Okay, right. Okay, and the left of 90 will be the same as usual, 82 and 89. Okay, now after merging, you see the parent has become deficient or not. Yes, in this case parent has become deficient. Okay, parent has become deficient. So this internal stage, it's shown here. After merging, this has happened, but the parent has become deficient. Now this deficiency should be removed. So can it borrow from its nearest sibling? Yes, it can borrow from its sibling, because sibling is having more than minimum keys. Okay, so it can borrow. So now it is borrowing from the left sibling. So we are performing right rotation. So when you perform right rotation, what will happen? When you perform right rotation, this 81 will come down. Okay, so this node will become 81 and 90. This node will become 81 and 90. 81 will come down, right? Yes, 81 will come down. So this node will become 81 and 90. Okay, and what will happen? This 81 will be replaced by 75. This 81 will be replaced by 75. Okay, so 75 is not here no more. But now what will happen to the 75's right child, right subtree? So this is a question. Okay, this what will happen in the sense, this will become the left child of 81. This will become the left child of 81. Okay, and 81's right will be this 82 and 89, and 90's right will be 92, 93, 110 and 111. Okay, so this is the change that will happen. Okay, this you should remember when we are performing this rotation. If there is a right child, okay, that node, then the right child will become the left child of uh, the nearest sibling. Okay, when you are performing right rotation. When you perform left rotation, similarly, when you perform left rotation, if there is a child, then uh, the left child will become the right child of the other sibling. Okay, fine. So this is the updated tree. You can see here what happens. 75 goes to the top. Okay, and 81 come down. 81 to the 81's left we have 78 and 79. 81's right we have 82, 89. 90's right we have 92, 93, 110 and 111. Okay, so this is the case after deleting which one? 100, right? Okay, next let us see how to delete 6. So 6 less than 75 less than 10, it's here, we can delete directly. Okay, just it will be deleted, that's it. Okay, next 27, how to delete 27? 27 less than 75, greater than 10 and less than 50, so follow this path. So it is here 27, again it's in the leaf node, and the node is having more than minimum keys, so we can directly remove 27. Next 60, how will you delete 60? 60 is here, so I mean 60 is less than 75, it's greater than 10, greater than 50, so it's here. So 60 is in a non-leaf node, so it should be replaced with either the in-order predecessor or the in-order successor. Okay, so now let us see that, let us assume that it is getting replaced with the in-order predecessor. So in-order predecessor is 52, so 52 will come here. Okay, this will be replaced with 52 and this 52 will be removed. Now after removing this 52, what happened? This node has become deficient, so it has to borrow either from the left sibling or right sibling. It cannot borrow from the right sibling, it has to borrow from the left sibling. So when it borrows from the left sibling, what will happen? This 50 will, we have to identify the minimum key of the parent, so this 50 will come down. So this node will become what? 50, 51. Okay, this will come to the leftmost end, so it will become 50 and 51. Okay, this node will become 50 and 51, right? Yes, this node will become 50 and 51, and this what do you call, this 50 will be replaced by 16. Okay, this 50 will be replaced by 16, right? So now the deficiency is removed. Yes, so this is the updated node, 10, 16, 52 at the top. Okay, to the left of 16 we have 14 and 15. To the right of 16 we have 50, 51. To the right of 52 we have 68 and 73. Okay, fine. So this is how we remove 60. Okay, then let us see how to delete 16. 16 again, 16 less than 75, it's greater than 10, it's here, it's in a non-leaf node, so it should be replaced with either in order successor or in order predecessor. Okay, so what we are going to do, so I think here we are replacing with in order predecessor. Okay, so if you replace with in order predecessor, what will happen, in order predecessor is 15. Okay, so 15 will replace this 16. Okay, 16 is the one which we are deleting, right? Okay, but now this node has become deficient, so you have to merge. So because it cannot borrow either from the right sibling or the left sibling, because both of them are having minimum keys. So if you merge, what will happen, the minimum, I mean you have to locate the minimum key from the parent, which is 10. So this 10 will come down, so this node will become something like this. I mean 4, 4, 5, 10, 4, 14, 4, 5, 10 and 14, that will be the new node. Okay, and 10 is not here, 15's left will point to this. Okay, so that will be the updated thing. Yeah, 15's left will point to 4, 5, 10 and 14, and 15's right is pointing to 50 and 51, and other things are same. Okay, fine. Now let us see how to delete 50. Okay, if you delete 50 from, where is 50, 50 is less than 75, is greater than 15 and less than 52, so it's here. So if you delete 50, this node will become it's in a leaf node, so you can delete it, but this node will become deficient. Can it borrow from its right sibling or left sibling? Yes, it can borrow from the left sibling. So if it borrow from the left sibling, what will happen, this 15 will come down, so this will be 15, 15 and 51. Okay, and this 15 will be replaced by 14. Okay, and this 14 will be removed, so at the top we'll have 14 and 52. Okay, towards the left of 14 we have 4, 10 and, I mean 4, 5 and 10. Okay, and towards the right of 14 we have 15 and 51. To the right of 52 we have 68 and 73. So that's it about deletion. Okay, you can try one thing. See, you try deleting 81. Okay, you try deleting 81. Okay, when you delete 81, what will happen, 81 should be replaced either with the left sibling, I mean left predecessor, I mean in order predecessor or in order successor. So in order predecessor is 79, in order successor is 82. Okay, so if you replace say 81 with 82, if you replace 81 with 82, okay, so this node will become deficient, this node will become deficient. Okay, then again you have to bring this 82 down, you have to bring this 82 down, and this will become a new node. Now when you bring 82 down, this node will be converted to 78, 79, 80, 82 and 89, right? 82 and 89, that will be pointed by the left of 90, that will be pointed by the left of 90. Okay, this is not here. Okay, right, but now there is a deficiency here. Now how will you remove this deficiency? Can this borrow from here? No, it cannot borrow, so this should be merged. Okay, now if you want to merge this, what will happen, 75 will come down. Are you getting? So if 75 comes down, then what will happen, this will become 14, 52 and 90. Okay, so this is called shrinking the tree. Now the height of the tree will reduce. Okay, so at the top what will have 14, at the top we'll have, at the top we'll have 14, so here we have 14, 15 and 90, so 75 should come down, right? So we'll have 14, 52, 75 and 90. This will become the root, this will become the root, new root, okay, because 75 has come down, okay, right? To the left of 14 you have 4, 5 and 10. To the left of 14 you have 4, 5 and 10, okay. To the right of 14, to the right of 14 you will have 15 and 51 as usual, 15 and 51, okay. To the right of 52 you will have 68 and 73. To the right of 52 you will have 68 and 73, 68 and 73, okay. To the right of 75 what we will have? Right of 75 and less than, I mean to the right of 75 to the left of 90 what will have? This thing you will have 72, 78, 82, 89. That will be to the right of 75 and left of 90, okay. To the right of 90 what will have? To the right of 90 what will have? 92, 93, 110 and 111. 92, 93, 110 and 111, okay. So this step is called as shrinking the tree, okay. This step is called as shrinking the tree, okay. So here previously you see the height of the tree, it is 1, 2, 3, but after deleting 81 the height of the tree has become 2, okay, right, fine. So I think we have discussed all cases of deletion, so that's it. Let us stop here, okay. Thank you.